symmetry, but let's see what was next. No symmetry, none there. Oh, asymptotes were next. So this was the first one that actually does have an asymptote, and it has a horizontal asymptote. And I don't know why, or parenthesis. We write our asymptote as an equation, and I said it's a horizontal line at y equals 0. And again, if you wanted to check that, if you're like, is horizontal y equals 0? I can't remember. Go back down here where we wrote x minus x equals 0. That's a vertical line, so that's not it. But let's see what happens when I change it to y equals 0. Turn it back on. And if you hold that circle down, you get the option to change the color of the line. Well, it's not working with my stylus. Oh, there it goes. Or make it a dotted line. Okay, so you can see here now, that is the horizontal line. That's the asymptote. It is y equals 0. And then this in orange was, is there a vertex? So there is no change in direction on this graph. If I trace this from left to right, it's very slowly increasing at first, but it is increasing, and then it just shoots up. But it keeps going up and up and up forever. It never stops increasing. So there's no change in direction. So there is no vertex and there is no max or min. Okay, now the logarithmic, that is the inverse function. I'm going to turn log on. Remember we talked about inverses are a reflection across the line y equals x. Look at that. The red is the exponential and the blue is the log. Okay, so turn the exponential off. We're just going to look at the log for now. So instead of having that horizontal line, sorry, you can hear my dogs wrestling in the background. That horizontal line was the asymptote for exponential, but inverse x and y switch, remember? So I'm going to switch that back to x equals, and you can see that would make it a vertical asymptote. So we have a vertical asymptote here at x equals 0. We have an x-intercept at 1, 0, and no y-intercept now because of that asymptote. So that means my domain is now restricted left to right. I go from 0 to infinity, and I do not ever reach the 0, so I don't include it. But I go down forever and up forever. So my range now is not limited. So from exponential to log, since these are inverse functions of each other, you'll notice what was my range is now my domain. Now I change it to x because we're talking about domain. And what was my domain is now my range because x and y switch in inverses. Okay, now what was my x-intercept, which there was none, is now my y-intercept. So there's no y-intercept for this one. And what was my y-intercept becomes my x-intercept. Now, it doesn't stay 0, 1. It changes to 1, 0 because xy switch for inverses. Okay, there is still no symmetry. And now instead of a horizontal asymptote, there is now a vertical asymptote. And instead of being at y equals 0, it's at x equals 0. And again, there is still no change in direction. There is no vertex, no max, no min, not even a point of inflection for this one. Okay, so if you would like to make a side note over here. Oh, you know what? I don't even think I wrote the equations. Let's add those. F of x equals, now I'm going to write 2 to the power of x because that's what you're going to have to put in your calculator to get a visual of it. But remember that 2, that base value could be anything. So it's really b to the power of x, but we'll use 2. Okay, and then the log function is log of x. And the base value down here of the log could be anything. If you don't write anything, it's understood 10. Okay, and so you can look at those in the calculator. So I'm just going to make a note that these two are inverses. Okay, if that helps you when you're identifying their key features. Okay, you may or may not have noticed. I don't know why my S is moving with that. That's weird. Cube and cube root had that same relationship. Those were inverses. Okay, let's see what else. None of those, but cube and cube root are inverses of each other, and exponential and logarithmic are inverses of each other. So that's just good to know. And you can see that on the cube and cube root. They were both all reals for domain and range, so you can't really tell that they switched, but they did. And same thing with the x and y intercept. Since it was 0, 0, it's still 0, 0, because when you switch 0 and 0, they're still the same. All right, last but not least is the rational function. So the rational function is f of x equals 1 over x. So this one, in Desmos, I'm going to turn log off and turn rational on. And this is the one that has those curves in the quadrant 1 and 3. And so you can see that vertical asymptote I hadn't turned off. It's still an asymptote for rational, but now I also need that horizontal one. So I actually need both of those asymptotes that I had for log and rational. So I'm going to type in the y equals 0 as well. And I'm going to make it on dashed as well. See if it'll let me, come on. It's not liking my finger or the stylus to change. There we go. So now you can see those dashed red lines here. Those are asymptotes for this rational function. Okay, and you can zoom in if you want and see those. We get closer and closer and closer and closer and closer, but it's never actually going to reach it. It looks like it's touching it when you zoom out, but it never actually reaches that. Okay, so left to right, this is decreasing, and then we have to pick up our pencil and draw. This one is decreasing, so there's no vertex. It never actually changes direction, but there is a break in the graph, a break in the domain, left to right, and also bottom to top, there's a break in the graph at this horizontal asymptote. So when I go to give these key features, my domain and range both have a break. They go from negative infinity to 0, where the asymptote is. They do not include 0, so I use parentheses. And then I have a union because there's a break and it picks up again and goes from 0 to positive infinity. If I was writing that in inequality notation, I would say negative infinity is less than x is less than 0, union 0 is less than x is less than infinity. Okay, I would never use inequality notation here, but that's what it would look like. If you use the all real number symbol, it's all real numbers except for 0. So it's everything but 0. That's another way that that could be written. Okay, now the range is going to be exactly the same, except anywhere that you had an x, you would have a y, but the values, the numbers are going to be the same. So negative infinity is less than y is less than 0 union, 0 is less than y is less than infinity, or all real numbers except y cannot equal 0. All right, and then the x and y intercepts. This one has asymptotes on both axes, so this has none. It doesn't cross the x or the y axis. Okay, if we talk about symmetry, this is one that if I held my pencil down here at 0, 0, and I rotated that graph 180 degrees, it would appear unchanged. Okay, that quadrant 1 curve would end up down here in 3 and vice versa. So it does have symmetry about the origin. Okay, it is not symmetric about the y-axis. Let's see what else. No vertices, and we already talked about it has a vertical and a horizontal asymptote. So symmetric about the origin, okay, which was the same as like the cubic and cube root function. And then I'm going to abbreviate horizontal asymptote, HA, and vertical asymptote, VA, because it has both. And I have to remember which one's x equals and which one's y equals. So it's the axis that you cross. So when you have a vertical line, you cross the x-axis. So this is x equals 0. When you have a horizontal line, you cross the y-axis. So this is y equals 0. All right, and then we said there was no vertices or points of inflection or max or mins there. None of those. All right, so I'm going to stop this video here with the front side of those notes, and then there will be a second video for the back side.